In the morning class, we have seen about DC motors and generator problems. Now we go to the next topic. It is transformers. It is about transformers. So what is a transformer? So a transformer is a device that changes the AC electric power at one voltage to another voltage level. So, it is a device. So has the capability of changing the voltage level of AC, not DC. It can change only the voltage level of AC. AC electric power at one voltage level to another voltage level.
Sir,
Yes.
sir, make the full screen, sir. Slide at full screen.
Yeah. Full screen. Okay.
Yeah, okay, sir. Okay. Okay, sir.
Okay. So here in this transformer, we have two circuits, two coils. So the coil is not rotatory, it is stationary. There are two or more stationary electric circuits. So it is stationary electric circuits is here coils. In any transformer, you have two or more than two coils that are coupled magnetically. So it involves interchange of electric energy between two or more electric systems. So these transformers are used for changing the voltage and current levels easily. So if you are changing the voltage level from one point to another point, automatically the current level also changes because the power in a circuit is constant. So if you are changing the voltage level, automatically the current level also changes. If voltage level increases, current level decreases. If voltage level decreases, current level increases. So transformers are very needed. So it is easily changing the voltage and current levels easily. So these are step-up generator voltage. They are used for step-up generator voltage to appropriate voltage level for power transfer. Stepping down the transmission voltage at various levels for distribution and power utilization. So what is a transformer? So a transformer is a apparatus or equipment. It is a stationary one. So a transformer is a static piece of apparatus by which the electric power is transferred from one circuit to other circuit. So it is a AC circuit. It is transferred from one alternating current circuit to another alternating current circuit. So there is no electrical contact. This transfer of energy takes place through air, magnetically. Okay, there is no electrical contact between these two sides or two coils. The desired change in voltage or current. So the voltage level is changed or current level is changed without affecting the frequency. Frequency is same. So even though the voltage level increases or current level decreases, the frequency in which the AC wave is moving is same. So the principal work is mutual induction. Okay. It is a one type of coil transformer. This is a olden type of coil transformer. Nowadays it is not like that. First transformer. So this is the first transformer built in Germany in 1885, Budapest. So it is kept in the museum in Munich, Germany. This is the first transformer. We look at this transformer, you have two ends here, you have another two ends here. So one is primary, other one is secondary. There are coils available here. So in the structure of the transformer, it has two coils. Now both are inductive coils. They are separated by air, but it is linked through a magnetic circuit. So it is no electrical contact circuit, but it is connected with a magnetic current circuit. These two coils have high mutual induction. So what it happens means from the first circuit, the magnetic flux interact with this common magnetic current circuit. So it will transfer the flux to the next circuit. The next circuit will generate the voltage. Okay. So there are two coils, as I already told. So one of the two coils, one coil is connected to alternating voltage, input voltage. So the input voltage is alternating voltage. So that the coil is fed with the electrical energy with the help of source primary windings on in figure. So other winding is connected to a load. The electrical energy is transferred to the winding down to the other load. This winding is called secondary winding. So primary winding and secondary winding. When you look at this diagram, so here we are giving the input voltage. That is known as primary voltage. So the flux are generated. So this material is called magnetic material. So this will not pass the current, but it will pass the flux. Okay. So this is a magnetic material. It will pass the flux from this circuit to this circuit. The current will not flow from this through the magnetic material. Only flux will move through the magnetic material. There are some leakage flux available. Remaining flux will be go to the secondary circuit. So this will generate a voltage. That voltage is taken out. Okay. This is primary winding. This is secondary winding. The common material we are calling as ferromagnetic metal core. Okay. This is leakage flux. So we are passing the current, so it will create a flux. So it will reach the secondary winding and it will produce the voltage. The function of the core is to transfer the changing magnetic flux from primary coil to the secondary coil. So the primary coil has n number of turns, n1 number of turns, and secondary has n2 number of turns. So it is playing a major role in the function of the transformer. As I already told, it works in the principle of mutual induction. What is mutual induction? So the principle of mutual induction indicates that when the two coils are inductively coupled, and if there is a change in the current, it will uniformly induced in the other coil. This EMF will drive a current when there is a closed path is provided to it. So what I am doing is, so we are taking two coils, they are magnetically coupled. First coil produces flux. That coil interacts with the second coil. This flux will generate a EMF. If the second coil is short circuited, it will produce a current. So this is a principle working mutual induction. So when the alternating current flows in the primary coils, a changing magnetic flux is generated. So we are giving the AC current in the primary coil. A changing magnetic flux is generated around the primary coil. This changing magnetic flux is transferred to the secondary coil through the iron core. The changing magnetic flux is cut by the secondary coil, hence an EMF is induced in the secondary coil. Now, if the load is connected to the secondary coil winding, this EMF drives a current through it. So, the magnitude of the output voltage can be controlled by the ratio of number of primary coil and secondary coil. Okay. Now, if a load is connected to a secondary coil, this EMF drives a current through it. The magnitude of the output voltage controlled by the ratio. The primary coil has low number of turns, secondary coil has high number of turns. Or primary coil has more number of turns and secondary coil has less number of turns. So the ratio is N2 by N1. So secondary coil by primary coil. That is the ratio. So the magnitude of the output voltage depends upon this ratio, N2 by N1. If there is no load connected in the secondary winding, so it will produce a EMF. So if it is connected to a load, a current will flow through it. Okay. The frequency of the EMF generated mutually induced EMF is the same frequency of the input voltage. Both the input voltage frequency and the EMF generated in the secondary winding frequency both are same. Now we have to derive the equation. So there is a magnetic iron core. N1 turns, N2 turns, V1 I1, V2 I2, primary winding coil A, secondary winding coil B. That's a flux pi. EP primary voltage, ES secondary voltage, pi magnetic flux. EP equal to ES. This is the voltage generated in the coils, primary and secondary coils. Okay. So first we are going to see what is inside the transformer. So there are two types of construction of transformer, magnetic core and windings and coils. These are placed inside the transformer. So what is inside the magnetic core? We are seeing there is a rectangular box. So this is known as magnetic core. This core is either square type or rectangular type. So it can be made in the form of square or it can be made in the form of rectangular in size. It is further divided into two parts, vertical and horizontal. So the vertical portion in which the coils are wound are called limb, while the horizontal portion we are calling as yoke. So after producing the square or rectangular shape, we are dividing it into two parts. One it is limb, other one is yoke. The vertical portion we are calling as limb, horizontal portion we are calling as yoke. Okay. This core is made up of laminated core type constructions because to reduce the eddy current losses. So normally high grade silicon steels are used. So another material used in transformer is winding. This is a actual current flowing material. So the conducting material we are calling as a winding. These coils are wound on the limbs. So this side one limb, other side another limb. The coils are wound on the limbs and insulated from each other. So why we are insulated means it should not be direct electrical contact. So we are insulating each other. There are two different windings on wounds on two different limbs. So you can connect primary winding, you can connect secondary winding. So there are two different windings. One means we are constructing the winding. The leakage flux increases, which affects the performance and efficiency of transformer. So to reduce the leakage flux, it is necessary that windings should be very close to each other to have high mutual inductance. So while constructing the transformer, the air gap between these two fluxes, two windings should be minimum. Then otherwise, if the air gap is very more, then there will be more leakage flux and more voltage will be wasted. So there are two types of construction. One it is core type, another one is cell type. So first one is core type. So in this core type, one magnetic circuit, and you can also use cylindrical coils also. So in this diagram, if you see, it is a L type. So L type, you can use L type and T-shaped laminations. So here there is only one magnetic circuit. You can also use cylindrical coils. The laminations are L and T shaped laminations. Commonly, primary winding are wound on one limb, while secondary on the other, but the performance will be reduced. So in order to increase the performance, you have to reduce this air gap in core type. To reduce the performance. So here if you see these laminations, this is cell type, this is core type. Okay. So the cell type lamination is in the shape of E, core type lamination in the shape of L. We see here. Here you can use either L and T shaped. Here it is L shaped. So it is a core type construction. So in the cell type, two magnetic circuits are used. So here only one shape. Here there are two magnetic circuits are used. The winding are so I will so in this type, two magnetic circuit are used. Here, if you look at this cell type, it has three limbs. Here it is L shaped and T shaped. So here the winding is one on the center limb. It is one on the center limb. For the cell type, each high voltage winding lies between two voltage portions and reaching the high voltage winding. So here subdivision of windings will reduce the leakage flux. Here one winding, here another winding. So the air gap is very minimum. in the cell type. This type of construction is used for higher voltage because the air gap is minimum, the leakage flux is minimum. So high voltage can be produced used in this cell type transformer. So in the L type transformer, it is used for low voltage transformer. So core type transformer, it is only used for low voltage, and cell type is used for high voltage transformers. So this is the actual construction for a core type transformer and a cell type transformer. Next one, losses. So in the construction, you have magnetic core, windings. So what is the magnetic core is made up of? How the windings are connected? What are the two types of construction? Core type and cell type. How the windings are connected in the core type and how the windings are connected in the cell type. If you ask for principle, you should explain the principle of mutual inductance. So the principle of mutual inductance is employed in transformer. The voltage is applied to the primary winding. So the flux will interact with the secondary winding. So the secondary winding will produce an EMF. The secondary winding as a closed path, it will produce a current. So this is the working principle of a transformer. Next one is losses. So losses, you have copper losses, iron losses in transformer. So first one is copper losses. So it is the losses occurred in the resistance in both in primary and secondary coil. We know the heat loss is the copper loss. So heat loss is equal to I squared R. I squared R. The magnitude of the copper loss depends upon the current flowing through the primary and the secondary. Next one is iron loss. So iron loss is constant. So it depends upon the voltage, where the copper loss is dependent upon the current. So these laws are not dependent upon the phase angle. So it is only dependent upon the voltage and the current. So since losses are not dependent upon the phase angle, so always transformers are rated in kVA. Rating of transformer is expressed as a product of voltage and current. It is called VA, rating of the transformer. Since it is expressed in heavy means kilowatt, kilo VA means it is kVA. So most of the time, the transformer is rated in kVA only. So if you want to buy a transformer, you have to tell how much kVA transformer you are needed for your application. So the rating of the transformer is VA or kVA. VA means small transformer. kVA means high range transformer. So during magnetization, another losses are, so iron losses are classified into two types. One it is hysteresis loss, another one is eddy current loss. So hysteresis loss is during magnetization and demagnetization, due to hysteresis effect, some energy losses occur in the core, which is called hysteresis loss. So eddy current loss, the leakage magnetic flux generates a EMF in the core, produces a current called eddy current loss. So a transformer said to be ideal if it satisfies the following properties. But no transformer is ideal in practice. So every coil has some resistance, so it has some losses. The ideal transformer, we are assuming that it has no losses. There is no flux leakage. The winding resistance are zero. Small current is required to produce the magnetic field. These assumptions are made such that we have an ideal transformer. But actually it is not like that. So what is the ideal transformer working? So while the practical transformer has winding resistance, some leakage flux and has little bit losses. So next one is application and uses. The transformers are used in television, photocopy machines. It is used in camera as a flyback transformer. So it is used for coupled in amplifiers, and it is used in transmission and distribution side. So we many transformers are available in the roadside for the distribution line for your house in order to supply So it is come from the electrical post. All the electrical posts are connected to a transformer. So that is distribution transformer. Similarly, transmission side also you have big transformers. They are called transmission transformers. So transformers are widely used in all the electrical engineering. So it is an essential part of all electrical engineering. So next we see some problems in this transformers. We go to the problems. So all of it, turn your camera sideways, then only they will be visible.
First problem. A 20,000 bar 200 volt 20 kVA transformer.
போர்டு மிரர் இமேஜ்ல இருக்கு.
மிரர்ல இருக்கா?
லெஃப்ட்ல இருந்து வருது.
ஓகே. இப்போ
சார் சுந்தர் சார் சார்
இப்போ இருக்கா?
இப்போ கரெக்ட்டா
இப்போ பாருங்க. ஓகே.
இப்போ கரெக்ட்டா இருக்கு சார்.
ஓகே. So it has 56
ஃபுல் போர்டு விசிபிளா இருக்கு.
சார்.
ஓகே சார்.
66 stands in secondary. So you have to calculate what is the primary turn. Next one, what is the primary and secondary full load current? Primary and secondary full load current. Secondary full load current. Okay. So this is the problem. 2000 bar 200 volt 20 kVA transformer has 66 turns in secondary. So I have to calculate the primary turns, primary and secondary full load current. So I have to draw the diagram. For this problem I am drawing a diagram. So how you have to draw a transformer? So every transformer has a primary and a secondary. So this is the symbol for the transformer. So this is the magnetic core. This is primary coil. This is secondary coil. So they are given it is 2000. Input is 2000 volts. Output is 200 volts. Okay. Next one, they are given the power. So I have told here the power is kVA because it does not depend upon the phase angle. The power factor is not important in transformer. So we are giving the power in kVA. Okay. So here they have given it is 66 turns. Okay. So this is I1, we are calling as E1, this is N1, N2, I2, the voltage generated is E2. Okay. So these are the given data. So I have drawn the diagram. So from the given problem I have drawing a diagram. So you know the voltage V1, V2, N1, these are the terms we know. So it doesn't know other terms, we have to find out. So in transformer, the ratio of transformer K equal to N2 by N1. Okay. In transformer, we are calling as a transformer ratio K, which is equal to N2 by N1. So N2 is number of turns in secondary, N1 is number of turns in primary. So you know the N1, it doesn't know the N2. So you know the N1, it doesn't know the N2, you cannot find this. For this problem, so we are moving to finding the current. Okay. We know the power, you can easily find the current. So I1 equal to, so power is 20 kVA, so 20,000. The voltage is also known, 2000. Power divided by V1. Okay. So power divided by V1. So 20,000 by 2000, it is 10 amps. Okay. So I will find the current here, 10 amps. So as I already told, there is no losses here. So assume no losses. So same power will be generated in the next side. If there are losses, power will be reduced. So since the problem, given that there is no losses, so you have to have the same power at the receiving end. So you can easily find the secondary current also. I2 equal to P by V2. So P is same thing, 20,000. Voltage is 200, 100 amps. Voltage is 100 amps. So I1 is so you have find the I1. So I have find the current I1, I have find the current I2 with the help of power. So I know the power, I know the voltage, I find I1. Since there are no losses, all the power will be transferred to the other side. So I have find I2. Next one, we have to find the N1. So this ratio can be written as K is equal to N2 by N1, which is equal to V2 by V1, which is equal to E2 by E1. The K can be found by number of turns N2 by N1 or V2 by V1 or E2 by E1. So we know the V1 and V2. So we can easily find the K. K equal to V2 by V1, which is equal to 20, 200 by 2000. Equal to 1 by K equal to 1 by 10. So we are finding the now we have to find the N2. So N2 equal to K into N1. So 1 by 10 into 66. 1 by 10 into 66. So it is 6.6 turns. Okay. So what I am doing is, from the problem I am identified that it is a step down transformer. 2000 to 200. So number of turns in the secondary will be lower. Okay. So it has 66 turns in secondary. Sorry, I have written wrongly. This secondary. So I have to find the primary turns. So K is N2 by N1. So I want to find N1. So N1 equal to N2 by K. N2 by K. So N2 is 66 divided by 1 by 10. 660 turns. 660 turns. So they are given secondary, it is 56 turns. I have to find this. The transformer ratio is N2 by N1 or V2 by V1 or V2 by V1. So I know the V2 and V1. So I am finding the K by using this equation. V2 is 200, V1 is 20,000. So K is 1 by 10. So from this equation, K equal to N2 by N1, I want to find N1. So I am moving N1 and K here. So N1 is equal to N2 by K. So N2 is 56, K is 1 by 10. So you get a value of 650 turns. Similarly, I want to find the current I1. So you know the power, you know the voltage, divide this, you get the current. Similarly, that current I2 equal to P by V2, 1000 amps. Write it down. So after completing, you put in the chat box. I will see. So after completing this problem, we move to the next one. So in this transformer unit also you have to study the construction, working principle, EMF equation. So this EMF equation is there, we will see later. So EMF equation is there. Then you have to have some problems in EMF equation. Finally you have applications. So next one is single phase induction motor. So we complete the syllabus within this week for unit 2. So next we go to the unit 3, model 2, but unit 3. So it is about electronics, diodes, rectifiers, transistors and so on. In the meantime, during CA we have revision class. So before the exam we have a revision class for CA. So we complete the syllabus, we will solve more problems, more different types of problems in all the units. So first unit is a vast one, you can see many problems, different types of problems. So if you have completed the problem, you put completed in the chat box. Okay, so you have completed. So I am moving to the next problem. So an ideal, so ideal means it has no losses. So if I say ideal transformer means it has no losses. So ideal 25 kVA transformer has 25 kVA transformer has 500 turns in primary winding. 500 turns on primary winding and 40 turns on secondary winding. 40 turns on secondary winding. Primary is connected to 3000 volts 50 hertz supply. 3000 volts 50 hertz supply. Calculate primary and secondary currents on full load. Primary and secondary currents on full load. Secondary EM of full load. Next one is secondary EM of last one is maximum core flux. Maximum core flux. So this is the problem. So first you have to write the given data. So what is the data? So they have given data. So power given 25 kVA. Then N1, N2 are there. N1 is 500, N1 is 500, N2 is 40. Then voltage given, frequency given. Primary V1 is given, V1 equal to 3000 volts. F is 50. These are the given data. From this we have to find the primary current and secondary current. Here also they have given it is the ideal transformer. Since ideal transformer there is no losses. All the 25 kVA will be appear in primary as well as secondary. Primary as well as secondary. We take the same diagram. So input is voltage is 3000 volts, 25 kVA. So I1 is 500 turns I2 is 40 turns. Ideal 25 kVA transformer. V1 is 3000 volts. Frequency is 50 hertz. So you write the frequency separately, 50 hertz. Okay. So after drawing the diagram, we have to first find the primary current. So we know the power, we know the voltage. Primary current I1 equal to P by V1. This is equal to 25 kVA. 25,000 divided by 3,000. So it is 25 by 3, 8.33 amps. Next one, you have to find the secondary current. So since the ideal transformer, no losses, so P by V2, 25,000. I doesn't know the voltage here. So I have to find the K. So I cannot apply this because I doesn't know the voltage V2. So I go to the ratio K equal to N2 by N1. K equal to N2 by N1. What is N2? We have given N2 is 40. N1 is 500. So 40 by 500. 4 by 50. Okay. This is the ratio. From this ratio, I have to find the V2. K equal to V2 by V1. So I know the K. From this I can find the V2. V2, after finding V2, I can find the I1. So V2 is the secondary EMF. Okay. From this I find the K. After that I find the V2. So I find this EMF also. Next I find the secondary EMF current also. So maximum core flux is different. So write down this, write the problem, write given data, draw the diagram. So what I am doing is first I am finding the current, power divided by voltage. Next here I am not able to find because I doesn't know the voltage here. So I am going to the formula K, ratio K, N2 by N1. So I get the ratio. From this I will find the secondary EMF and secondary current. Finally, we will move to the maximum core flux. So write it down. So after finishing the problem, you put it completed. rub the question. So I have found the primary current. Now I have to find the secondary current. So I doesn't know. So I go to the ratio, transformer ratio. So I have found out K. So K is also equal to V2 by V1. So I now want to know the V2. So V2 equal to V1 into K. V1 is 3000. K is 4 by 50. This is equal to 60 into 4, 240 volt. V2 is 30 into 4, 3005 divided by 50, 60 into 4, 240 volt. So I find the secondary EMF. Secondary EMF is equal to 240 volt. Now I can easily find the current I2. This is V2. I2 is equal to V by V2. E is constant, 25,000. It is 240. 25,000 by 24. 1. 10 means 0. 100, 104.1 amps. Okay. So I have found the secondary current. Next one we have to find the flux per pole. So it is a different formula. So we have to find the flux per pole. So the final question is flux per pole. So in EMF generated in transformer is equal to E equal to 4.44 F pi N1 or N2. The equation for transformer is 4.44 pi F into N1. 4.44 F pi into N1. So now we have to find the pi. So remaining things we know that. So we know the frequency 50 Hz. We know the N1 tan. We know the EMF generator. So you can either take E1 or N1. So if you take E1, you have to take N1. If you take E2, you have to take N2. So corresponding number of turns you have to take. Corresponding EMF you have to take. Okay. So I am taking E1. So primary voltage. I am taking N1. So E1 is 3000 volts. N1 is 500. Okay. For E1 3000. 4.44, F is 50, pi I don't know, N1 is 500. Okay. Now we have to find the pi. Pi equal to this get cancel, this get cancel. So remaining things we can put 30 divided by 4.44 into this 0 also we can cancel. So 3 divided by 4.44 into 5 into 5. So pi value is 27 into 10 power minus 3 Weber, which is equal to 27 milliweber. So the EMF equation in a transformer is 4.44 F pi N1. So 4.44 is a constant, F frequency, phi is the flux, N1 is the number of turns. If you take EMI primary coil side, you have to take E1 and N1. If you take secondary side, you have to take E2 and N2. For example, the same problem I am taking E2. E2 equal to 4.44 F by N2. Okay. For E2 voltage is 240. 4.44 into 50 into 5 into N2 is 40. Okay. So 0, 0 cancel. So this will become 6. That's all. So pi equal to 6 divided by 4.44 into 50. 6 divided by 4.44 into 50. The same value. Here 4.44, here 25, here 3. Here 6 into 50. Same thing. So 27 millivolts. So you can take either side. Whether you take E1, then you have to use N1. If you take E2, you have to take N2. So it is not necessary you should take E1. You can take anyone, E1 or E2. So final answer you have to find the flux. So E1 equal to 4.44 F by N1 or E2 equal to 4.44 F by N2. Write it down. After writing, put completed. We move to the next problem. So this type of problem should be mostly asked in previous final questions. So it is simple only. You should know the relationship. What is power, voltage and current, and what is the ratio K, and another formula, what is EMF generated in a transformer. These are the three formulas you have to use. So K is V2 by V1 or N2 by N1 or E2 by E1. Only three formulas are there in a transformer. Okay. Three formulas are there. Shall we go to the next problem? Have we written now? Have you written the problem? So very simple only. So you have to find the current by using K ratio, by finding the voltage, and easily find the current also. Then EMF equation, you apply the EMF equation, phi is unknown, So you move the other values, you get the 5. You can either use primary coil or secondary coil. So only 3 formulas: power equal to VI, and E equal to 4.44 FIN, and K equal to E2 by V1 or N2 by N1 or E2 by E1, which is also equal to I1 by I2. So I am writing the equation. K is equal to E2 by E1 or V2 by V1 or N2 by N1 or I1 by I2. So these are the 4 formulas for K. You can use any formula. You can use K equal to E2 by E1 or V2 by V1 or N2 by N1 or I1 by I2. So if you use the formula K equal to I1 by I2, you can find there itself. So instead of finding EMF and finding the current, I can directly find here. So here I can use, so I want to know I2. So I2 is I1 by K. I1 by K. So I1 is 8.33 divided by 4 by 50. So this will become 104.1 amps. So you have to know 3 formulas. P equal to VI, power equal to VI. Another formula, E equal to 4.44 FIN. We use primary coil, it is E1 and N1. We use secondary coil, it is E2 and N2. K is equal to E2 by E1 or V2 by V1 or N2 by N1 or I1 by I2. So we go to the next problem. I hope you have written this. A single phase 2200 bar 250 volt 50 hertz transformer has an area of 36 centimeter square, area of 36 centimeter square, and maximum flux density is 6 Weber per meter square, 6 Weber per meter square. So that is 36 mm square, 6 Weber per meter square. Next, you have to calculate number of turns in primary and secondary. Number of turns in primary and secondary. So this is the problem. So you have to find N1 and N2. N1 and N2. So first write the given data. So given data is V1 2200, V2 250, F 50 Hertz, area 36 centimeter square, which can be written as 36 into 10 power minus 4 meter square, and flux density B equal to 6 Weber per meter square. So these are the given data. So the V1 is known, V2 you know, we can see they are given, area given, and the flux density is given. Now we have to find the number of turns in primary as well as secondary. Write it down. So after finishing this, put completed in the chat box. So have we completed the left side? So we completed the left side of the blackboard. Okay, thank you. So you have three formulas, E1, K and power. So in this problem, so there is already we have seen this formula. Flux density equal to flux by area. That formula is used. Flux density equal to flux by area. So you know that flux density equal to pi by A. So they have given the A, they have given the pi B, so you have to find the phi. Phi equal to B into A. B is 6, that is 36 into 10 power minus 4. Okay. This is equal to 216 into 10 power minus 4. So you have to find the phi. Now we have to find the N1 and N2. How we can find? So E1 equal to 4.44 F pi N1. So I want to find N1. So E1 divided by 4.44 F pi, which is equal to, so E1 given 2200, 4.44, 50, pi is 216 into 10 power minus 4. So N1 is So after substituting this, you get a value of 459. 459. The number of turns in primary is 459. Similarly, N2 is E2 divided by 4.44 F5. So E2 is, they have given 250, 4.44 into 50 into 216 into 10 power minus 4 is equal to, so the number of turns is 52. Number of turns is 52. So from the problem, we have to find N1 and N2. So N1 and N2 can be found by this equation, because we can find the K by using V1 and V2. There is no N1 and no N2. So only thing, they are given area and field. So from this we can find the phi. After finding phi, you have to go to this formula and you can substitute this and you can find the N1. Similarly, you can find N2 in the same formula. E2 equal to 4.4 F pi N2. So N2 equal to E2 by 4.4 F pi. You get the value of N2. So like this you can find the N1 and N2. If you know N1 or N2, you can easily find the other by using the K. If it doesn't know N1 and N2, by using the flux only you can find the values N1 as well as N2. So write it down. Hello?
Yes, sir.
Okay, sir. Okay. There's a sound getting but.
Yeah, okay.
So what the given data they are given, from that you have to find the solution. So you know all the formulas. So which formula is suitable for this problem? You should understand. So all the formulas you already know this. So you have to use a suitable formula and you have to go to the answer. So have you finished the right hand side? If you finish right hand side, put in chat box I have completed right hand side. Next we move to the next problem. So in this unit, you have DC machines, AC machines is transformers and induction motors. Induction machine, actually it is induction machine. So this, we are studying the transformer. In the next class we see about induction machines. So within this the unit 2 is over. Okay. Next we move to the unit 3. So within October 12 we have to complete the model 2. So if we finish the model, we can revise the class. So after internal test, we can start the model 3. Actually, it is 4 hours. Now it has become 6 hours. 5 hours, 4.5 hours. One day we see the lab, what are the machines are available in electrical machines, what are the DC machines available, what are the motors used in labs, everything we see in one class. Shall we move to the next problem?
Students reply me soon.
Rodham only active, okay. What about others?
Yes, sir. Students completed.
Yes, sir. So an ideal transformer. So why we are calling as ideal transformer means there is no losses. If there are losses means the secondary power will be changes, voltage will change, current also change. Okay. So ideal transformer has 90 turns in primary. So in the primary side it is 90 turns and 2250 turns in secondary. 2250 turns in secondary. So they have given N1 and N2 is connected to 200 volt 50 hertz supply. They have given the primary voltage, they have given the frequency also. Next one, they have given the load across the secondary draws a current of the load across the secondary. Load across the secondary draws a current of draws a current of 2 amps at 0.8 power factor. At 0.8 power factor lagging. Lagging means we are put lag. Leading means we put lead. Okay. So what is the question is, you have to find the primary current. First one, find peak primary current. So first question is primary current. So negative one is, what is the flux? Flux linked with secondary. Flux linked with secondary. Secondary or primary, flux is common only. Pi is common only in the primary as well as secondary. They have asked what is the flux linked with secondary. Okay. Question is, an ideal transformer has 90 turns on primary side and 2250 turns in secondary. So it is connected to a 200 volt. Input voltage is 200, frequency is 50 hertz. So they have connected a load. So load is having 2 amps and it has a 0.8 power factor lagging. So you have to find the primary current, you have to find the secondary voltage, you have to find the phi. Okay. You can easily find this. First I am writing the given data. So I am rubbing this. So given data. N1 90 terms, N1 equal to 90, N2 equal to 2250, V1 equal to 200, F equal to 50, F equal to 50. Load is 2 amps, it is I2. So I2 equal to 2 amps. Power factor 0.8 lag. Okay. So these are the given data. So you have to find primary current, flux linked with the secondary. Okay. So we have the formula K. So you know N1 and N2. You can easily find K equal to N2 by N1. 2250 by 90. So 245, 25. K value is 25. Then you can easily find V2. V2 K equal to V2 by V1. V1 is equal to V2 by K. V1 equal to V2 by K. We necessary V2. So V2 equal to K into V1. K into V1. K is 25. V1 is 200. 25 into 200. It is 5000 volts. So I have find the secondary voltage. Secondary voltage. So our aim is to find the primary current and flux linked with the secondary. Okay. So I have found V2. So how we can find K1? So K is also equal to I1 by I2. So I want to know the I1. So I1 equal to KI2. K is 9. I2 is 2, which is equal to 18 amps. So I1 is 18 amps. K equal to I1 by I2. I want to find I1. So K into I2. K we have already found 9. I2 is 2 amps. So I1 equal to 9 into 2, 18 amps. So I have found V2 also. It is 5000 volts. Now we have to find the flux linked with the secondary. So we have to use the formula E2 and N2. So complete this. So after this we can finish this. K is 25, sorry, K is not 9, it is 25. So 25 into 2, it is 50 amps. So we have found K equal to 25. So 25 into 2, it is 50 amps.
Students, once you completed, inform me. We can go for the next topic.
So we have found the primary current, secondary voltage. Next one we have to find the flux linked with the secondary. So one more step is there. You finish this. So I wrap this question. So first line. So you have to find the flux linked with secondary. So E2 equal to 4.44 F5 N2. So E2 I know it is 5000 volts. So pi equal to E2 divided by 4.44 into Fn2. Okay. So E2 5000 divided by 4.44. F is 50. F is 50. N2 also given, it is 2250, 2250. So you have to give a value of pi is 0.01 Weber, 0.01 Weber, 0.01 Weber, 0.01 Weber. So by using the K, I have found the ratio. Then I can easily find the I1. So by using K itself, I find the V2. Then I use the EMF equation to find the flux. So this type of problems only come. So you have to use the same three problems. formulas. One it is K, and one is E, another one is power. So these three formulas are used in different ways in order to find the final answer. Okay. So after completing this, we go to the next topic.
Students, anyone completed? Post in chat box. Naveen.
Okay.
Naveen. 112 Naveen. 112 Naveen. Are you there?
Until Naveen is not there. Just a reply. Okay.
Okay, sir. We can go for the next topic.
It is not next topic. You have to ask questions what they have learned.
Yeah, okay. Okay.
We see, we ask one by one. Gautam.
Yeah, students, when you're telling the answer, just turn on your camera, unmute yourself, okay? Don't text in chat box. Turn on your camera and unmute yourself, okay? Don't don't text in chat box.
Gautam.
Sir,
What is a transformer?
the transformer is a device that changes AC electric power at one voltage level to AC electric power at another voltage level through the action of magnetic field.
So you are asked to open the camera also. I want to see your face. I want to see all your face. Turn on your camera. Okay. Thank you. Ivan Joseph. Ivan Joseph. What is step-up transformer?
Used to increase the voltage.
Increase the voltage.
Turn on your camera.
Increase the voltage, sir.
Ivan? Yeah, okay.
Increase the voltage. Very good. Thank you. Melvin. Melvin Thomas. Melvin Thomas, are you there? Melvin Thomas. No. Okay. Naveen. Naveen
It's
G.
not replying.
Okay. Prasant. Prasant.
The Naveen.
Navina. Okay.
Turn on your camera.
Turn on your camera. Naveen, you turn on your camera. Where is Naveen? Okay. So what is step-down transformer?
Sir?
What is step-down transformer? What is step-down transformer? So step up transformer means increase the voltage. Step down transformer means what? Decrease the voltage. Okay. Vishwajit. Camera on பண்ணுங்க.
சார் கம்ப்யூட்டரில் கேமரா இல்லை சார்.
ஓ கம்ப்யூட்டரில் பார்க்கலையா? ஓகே ஓகே.
ஆமாம்.
சரி, why this chance ratio is calculated? What is the use of chance ratio?
வாட் சார்?
What is the use of chance ratio? We are finding K.
Trans ratio sir.
Chance ratio.
Sir, primary winding to secondary winding, sir.
So if you know the primary voltage, you can easily find the secondary voltage by using transfer ratio. Okay?
Okay.
The Kabilan is there? No.
Yes, sir.
Another one person who didn't put assignment. So I will put 0 today. Sachin. Have you understand this electrical machines? So what is motor and what is generator? Can you differentiate motor and generator? Sachin? You have unmuted, but what happened? What is the difference between motor and generator? I hope you have joined the class. I couldn't hear anything. If anyone hears. Mohammed.
Javed.
Sir?
Can you tell the differentiate between motor and generator?
Sir?
What is the difference between motor and generator?
Generator is the current produced.
It will produce voltage. Okay. Motor?
Motor rotation current.
Rotational, it will produce rotational movement. Okay. Whether it is in DC machines, whether motor and generator construction is same or different?
Okay.
I am asking whether it is same or different. The machine is same or different for motor and generator for DC.